Hello, all, and welcome to our channel, your trusted source for demystifying cybersecurity. Today, we are diving into the 2021 OWASP Top 10 Web Application Security Risks. Cyber threats evolve, and staying informed is your best defense. By the end of this video, you will be well versed in these critical security concerns. So, let's begin. The OWASP, that is Open Web Application Security Project, top 10 vulnerabilities are defined based on a combination of factors that includes real world data, expert consensus, and the potential impact on web application security. Our first stop is broken access control. Think of it as having a weak lock on your front door. If your authentication isn't robust, attackers can easily break in, impersonate users, and access sensitive data. Imagine a web application where users can view their own profiles after logging in. Now, each user has a unique user ID, and their profile can be accessed via a URL like the one shown on this slide. That is https example.com profile slash user 123. Now, in a well secured application, the web server should validate the user's identity and ensure that they can only access their own profile. Now, it should check that the user is authenticated and the user ID in the URL matches their own user ID only. Now, any attempt to access another's user profile will result in an access denied error. Now let's consider what might happen in a scenario with a broken access control. Take an example, user A logs in and accesses their profile at https example.com profile user A. Now user A notices that the URL contains their username. User A decides to see if they can access user B's profile. They can manually change the URL to https example.com profile user B. Now, in a system with broken access control, the application doesn't properly validate the user's identity. User A can now view user B's profile, including potentially sensitive information like email addresses, personal data, or private messages. Now, this is a classic example of exploiting broken access control by tampering the request. User A manipulated the URL to access a resource or a user B's profile they shouldn't have access to. Now, let's move on to cryptographic failures. It might sound a bit technical, but don't worry, we have got you covered. Now, first thing first, what is this all about? Now, cryptographic failures, it symbolizes encryption. Cryptography that is not securely implemented can be easily breached. If a website stores user passwords without proper encryption, like for example, storing them in a plain text, it's like writing your password on a sticky note and putting it on your computer. It is like making it easily available so that anyone can access your system. Now, this vulnerability makes it easy for attackers to steal user credentials. Now, in this digital world, cryptographic systems rely on algorithms and keys to protect data. Let's dive into a more technical explanation. Let us first understand what is encryption and decryption. Now, encryption is used to turn your data into an unreadable format, or it is also called as ciphertext, using a specific algorithm and a secret key. So it's like turning your message into a secret code. Now, what is decryption? It is the other way around. To read the data, you need the right key and algorithm to reverse the encryption process and turn the ciphertext back into the original data, that is plain text. Now, how cryptographic failure occurs? Now, this occurs when there is a flaw in the encryption or decryption process. For example, if the encryption algorithm is weak or the secret key is easily guessable, your data is no longer secure. It's like using a cardboard box as your treasure chest. It might look secure, but it is not. Another example is password storage. A common example of cryptographic failure is improper storage by a website. Now, when you create an account and set a password, the website should store it securely. Now, here is what happens when there is a failure. In a system with cryptographic failure, your password isn't securely hashed. It might be stored in a plain text or using a weak encryption method. If there is a data breach, hackers can easily access your password, potentially using it for unauthorized access. So, in technical terms, cryptographic failure is when the encryption and decryption processes aren't robust. This makes your digital secrets vulnerable to unauthorized access. Whether in simple or technical terms, the key message is this: cryptographic failure means that the security measures you trusted to protect your data have failed, leaving your information at risk. Next up is injection. Now think of it as the Trojan horse of web vulnerabilities. But what does it really mean and how you can stay safe? That is something we are going to look further. Now imagine attackers sneakily injecting malicious code into your application. If your app isn't properly protected, these injections can manipulate data or even take a control of it. Let's begin by understanding injection vulnerabilities. These are security weaknesses that allow attackers to inject malicious data into your application. Think of it as a breach through your application defenses. In a poorly secured web form, if a user enters a malicious SQL query into a text field, it might execute on the database. This potentially reveals sensitive information or even might delete your data. Now, why should you care about injection vulnerabilities? Well, they are like giving a rogue agent access to your application's inner workings. Attackers can manipulate, steal, or even cripple your data. Now, let us understand this from a technical perspective. An injection occurs because the application doesn't properly validate or sanitize user inputs. Now, in the case of SQL injection, an attacker enters malicious SQL code into an input field. Now, what an attacker can do or what attacker does? The attacker crafts SQL code that exploits the vulnerability. For instance, they might put, quote 1 or 1 equal to 1 and end it by quote, single quote, in a login form to bypass the authentication checks. Now, when the application processes this input, it doesn't differentiate between user data and the injected SQL code. As a result, the query becomes select star from users where ID equal to the one that was mentioned in the quotes. This actually grants unauthorized access. So next in the top 10 vulnerabilities is insecure design. Now, insecure design, it is a term that can make or break your application security. Now, let's break it down and see how you can fortify your apps. Insecure design is like building a house without locks. If your application's architecture doesn't prioritize security, you are leaving vulnerabilities open for exploitation. Let us consider an e-commerce site that doesn't properly separate user data. Now, if a customer can access and modify another customer's order, it's a case of insecure design. This can lead to unauthorized actions and data exposure. Let us see some more examples of insecure design. First is inadequate session management. The website fails to manage user sessions securely. When a user logs in, if the system doesn't generate a unique session ID or doesn't implement session timeouts, as a result, an attacker can hijack a user's session. It can gain access to their account and personal information. Next is a lack of proper authentication. The website doesn't If a website doesn't implement strong authentication mechanisms, it might rely solely on a single factor authentication such as simple username and password. This actually leaves user accounts vulnerable to brute force attacks, or it is also called as credential stuffing, when attackers use stolen login credentials from other breaches. So imagine you are an employee in the marketing department and you have noticed the insecure design flaw. You can access and edit leave requests from other departments, using without using the URLs. So let's move on to the next security risk, that is security misconfiguration. Now, have you ever heard the phrase that a chain is only as strong as its weakest link? Well, that's precisely what security misconfiguration is all about. Think of security misconfiguration as leaving your windows wide open. Now, even a small misconfiguration can expose your system. So, regularly you should be reviewing your settings to keep everything locked down. Let's take an example. First example here is a misconfigured server or a cloud storage with a public access to sensitive files, like a database backup. It is akin to accidentally sharing your personal files with the world. Second is open server ports. Now let's illustrate this with an example. Imagine you are running a web server and you have a port open that shouldn't be. Now, from a technical perspective, the misconfiguration occurs because someone forgot to close an unnecessary server port. Now, this oversight creates an open gateway for attackers. An attacker scans the internet for servers with open ports. When they find yours, they can exploit this misconfiguration to gain access to your server. Now, what is the consequence? The consequences can be dire. Attackers might steal sensitive data, deface your website, or even use your server as a launching pad for other attacks. Let's now discuss about vulnerable and outdated components. Now, here is an analogy. Imagine baking a cake with expired ingredients. Not a good idea, right? The same goes for your software components. Let's see how you can keep them fresh. Now, vulnerable components are like using expired ingredients in your recipes. When you use software components with known flaws, it's an open invitation for hackers. So, you should always keep your components up to date. Example, let's imagine a simple web application that uses an outdated and vulnerable JavaScript library for rendering charts. Now, this library has a known security vulnerability that allows attackers to execute arbitrary code on the user's browser. What will happen in this scenario? Vulnerable component is the outdated JavaScript library. The application uses this library to display interactive charts to users. Now, what an attacker can do is an attacker identifies the vulnerability in the library and exploits it. So what they can do, they can craft a malicious script and inject it into user input field on the application. It can be a comment box. So what happens when a user views the page with this manipulated comment containing the attacker script, the vulnerable JavaScript library gets executed. Now, this can lead to various consequences. It can lead to stealing user session cookies, spreading malware, or even defacing the website. Next, which is also very important, is security risk is identification and authentication failures. Okay, so broken authentication. So this is a security vulnerability that occurs when an application's authentication mechanisms are flawed, or they are misconfigured, or they are improperly implemented. Now, in essence, it allows attackers to bypass authentication and gain unauthorized access to user accounts or sensitive data. Let us understand now what are the key aspects of broken authentication. First is weak password. One common aspect of broken authentication is the usage of weak, easily guessable passwords. Now, when users set weak passwords or use common ones, it becomes easier for attackers to crack them through the brute force or dictionary attacks. Okay. Next is credential theft. Now, the attackers can steal login credentials such as usernames and passwords through various means like phishing, keyloggers, or data breaches on the application side. Next way can be session management. Now, broken authentication can also manifest in improper session management. For example, failing to regenerate session IDs upon login, or not terminating the session securely when a user logs out. This can also create vulnerabilities. Now, next is predictable login credentials. If application uses predictable patterns for login credentials or session tokens, then attackers can exploit this predictability to impersonate other users. Next and very important point is lack of multi-factor authentication. Now, without multi-factor authentication, accounts are more susceptible to compromise. So, MFA adds an extra layer of security by requiring multiple forms of verification for access. Last but not the least point is session hijacking. This is also known as session fixation. This is a common attack related to broken authentication. Attackers steal or manipulate session IDs to impersonate a legitimate user. Now, among the top 10 security risk, next we are going to talk about is software and data integrity failures, or it is also called as insecure deserialization. Now, the name itself gives us idea what it is about. It is a security vulnerability that occurs when an application doesn't properly validate and handle data that is being deserialized. So, to understand this vulnerability, let's use a simple example with cookies. Now, imagine a web application that receives serialized data from a user, and that too without proper validation. Now, if an attacker sends malicious serialized data, it could execute harmful code on the server. Let us understand this in more detail now. Consider a scenario, okay, or imagine you have an online pizza ordering system. Now, this system uses cookies to remember your favorite pizza toppings and customize your experience. The server stores your preferences in a cookie and sends it back to the browser for future visits. So, what happens when you first order a pizza? The server creates a cookie that stores your pizza preferences. Now, these preferences are serialized, which means they are converted into a format that can be easily stored and transmitted. What server does? The server sends the serialized cookie to your browser, and it is stored there for future visits. The next time you visit the pizza website, your browser sends the stored cookie back to the server. Now, here is where the problem can occur. If the server doesn't properly validate and handle the data within that cookie during deserialization, it becomes vulnerable. An attacker can send a malicious cookie with tampered data, and the server, without proper validation, deserializes this malicious cookie, and the malicious data can contain harmful instructions or code. And what is the consequence of it? Consequences are that the server unknowingly executes the malicious instructions and it leads to potential security breaches. Alright, so next is security logging and monitoring failures. Security logging and monitoring, it is like having no surveillance in a bank. Okay, so without proper logs and monitoring, you won't notice suspicious activities or data breaches until it's too late. So comprehensive monitoring is very crucial. Let's take an example. Okay, if a financial institution doesn't log failed login attempts, okay, or monitor for an unusual activities, they might not detect a cyber attack until customers report missing funds. Last but not the least, and a very critical one is SSRF. So it is called as server side request forgery. SSRF, it is a security vulnerability that allows an attacker to make a web server perform actions on their behalf. It's like convincing a server to be your digital puppet. Now, how it works? Imagine you have a web application that fetches data from different websites, such as news articles or images. So, what it does, it makes HTTP requests for fetching this data. The server, acting as a web surfer, okay, goes to these URLs and brings back the information. Now let's say an attacker finds a way to manipulate where the server serves. Now I will understand this with an example. So let's consider that your application allows you to fetch latest weather data. So you enter your city and the application fetches weather information from a trusted weather website. But what if the attacker changes the URL to a different one, say an internal resource or the server itself? So if the server doesn't properly validate or restrict these requests, it might fetch internal data like a database or a configuration file, and it can send it back to the attacker. So what are the consequences of it? Now this could lead to data exposure, service disruption, or even unauthorized access to internal resources. So this is all about top 10 security risks, top 10 security vulnerabilities for web. Okay, so that's all folks. I hope you found this video helpful to understand the top 10 security risks. If you do, then please like and subscribe to our channel to stay updated. Thank you for watching.